Solving quadratics. Yesterday we did factoring that supports solving quadratics because that is one of the methods for solving quadratics. But let's back up a second here. Let's talk about what each of these words mean. Solving, that means you're going to get, your answer is going to be x equals something. Maybe x equals two somethings, but solve means get an answer. Don't just factor. Get it all the way to an answer. A quadratic, do you remember what a quadratic is? Fancy name for what kind of equation? An x squared, basically. If there's an x squared in it, it's a quadratic. I guess officially the right way to say that would be if x squared is the highest power, it's a quadratic. So ax squared plus bx plus c. And that little 2 up there means we'll have two answers. Occasionally it's the same answer, so it's a repeated answer, but we'll have two answers. What's the graph of a quadratic look like? Yeah, a U, a parabola. And so this still could look like a number of things if we put it on a graph. Could look like that. And that would have two answers. You know what? They all have two answers. Let me be more specific. That would have two real answers. Because it equals 0 at two different places. Do you know how to draw it so that it only has one real answer? It only has one x-intercept? So sideways wouldn't really be an x squared parabola. That'd be like a y squared parabola. So yes, that would have one answer, but it wouldn't be a parabola.
If the minimum's on the line.
Yes, if the minimum's on the which line? The x-axis. So if you had one that was just perfect like that, you'd have one real answer. And it would be a repeated root. Like we haven't talked about those, but you've sort of talked about those in Algebra 2. An x squared is a bounce. But you could also have one that doesn't have any real answers. So it never crosses the x-axis. So that has two imaginary answers. So that's kind of weird to think about. Like there's two answers, but they're not real. So there's not any x-intercepts, but there's still two solutions. They just have an I in them. Okay, so the imaginary stuff is what we did Friday. Factoring is what we did yesterday, a little bit. So we were sort of laying the background for what we're going to do today. Methods. Well, it kind of depends on who you ask and what you're talking about as like how many methods there are. I'm going to say there are 5 methods. There might be more than that, but for solving these, I'm just going to throw off my numbering, but I'll figure it out. Method 1 is with a calculator. That's not today. So we're going to pass on that. But it is a perfectly acceptable method if you have a calculator to graph it and see where it crosses the x-axis and have the calculator tell you what the answer is. So we're not going to do that, but that is a method. The other methods are no calculator methods. Those are the ones that we'll look at today. And you've done all of these before, so we're pretty much going to do one example of each. maybe 2 examples, and then we'll do a couple of sort of weird problems to get you ready for the worksheet. All right, factoring. Let's say we have 9x squared minus 11x equals negative 2. Any thoughts on what we should do first for that?
Move the 2.
Yeah, move the 2 over. We want it to be in the right format. We want it to be equal 0 so that then we can do whatever we want to do with it. So let's move the 2 over. And like generally speaking, you may not know if that factors or not, but since it's in the factoring section, and on the worksheet today there's there's some that say solve using any method. So you might try to factor, you might try something else. Let's see. I gotta go to a pencil now because this is guess and check time. It's either 1 and 9 or 3 and 3. On the back side, it's got to be 1 and 2. So I'm going to put the 1 and 2 in pen. In fact, what about the signs of those? Both need to be negative. Okay, now I'm switching to pencil because I don't know what's going on. Let's just try 3 and 3. Let's see, that would be negative 6x minus 3x would be negative 9x. So that doesn't work. Obviously, trading places with them doesn't do anything since they're both 3's. So let's try the 9 and 1. And if you do a little bit of math in your head, you can figure out, even before I put them in there, who do I want to be paired with the 2? The 1, because if I put the 9 across from the 2, I'm going to have 18. That's going to be too much. So let's leave x across from 2 and put 9 across from 1. And now we got negative 2x minus 9x, negative 11x, so we got it. Now, yesterday we would have been done. Now we're not quite finished yet. Cool.
What's the other way to factor that besides yesterday? You said there was another way to do it.
So teachers teach a variety of different ways, like the magic box.
Isn't there another way, like multiplying the first and last numbers?
Yes.
Okay.
Yes.
So I remember that from last year.
So there's an alternative method. Back to this problem. Yesterday we stopped there, like just said factor. But today we have an equation, and the instructions are going to be to solve. So, I mean, it's easy from here, but make sure you take the final step. You probably don't even show that step because you've done this so many times. X equals 1 and x equals 2/9. So those are our solutions. And you might remember there are other names for those. Solutions, zeros, x-intercepts, roots. That all means the same stuff. So we can use different words to ask for the same thing. All right, so that's one method, factoring. We did a whole bunch of that yesterday. The only thing we add today is take the factors and set them equal to 0, like the easiest part we save for today. All right, the square root method. This might be people's favorites because it's the easiest. So let's say we have 4x squared minus 28 equals 0. What do you think we want to do for that one? Okay, so you could factor out of 4, you could divide by 4. I'm going to move the 28 over, but I'm going to divide by 4 eventually. So either way, how about I just do both of those things at once and get x squared equals 7. And then, I don't know, take a wild guess. What do you think we do next if we're using the square root method? Square root both sides. There is one minor trick to the square root method, though. I didn't do it yet. Plus or minus. Remember that you got to have two answers. So the plus or minus gives you the two answers. Sometimes I'll call this the plus or minus square root method. That's a mouthful to say, but it reminds us to use the plus or minus. This is a great method, but it only works if b is equal to 0. Like if there's no middle term. Right? If there's a middle term, then you've got to do something else. But if there's no middle term, then it's really easy to go this route. Two x squared plus 36 equals 0. Why don't you try that one? Something a little bit different happens on that one, but something that I think you can handle. No, if you put, it looks funny if you do this, I3 root 2, but that's okay. What is not okay is if you put that plus or minus like in the middle somewhere, like 3 plus or minus I root 2. That's different. That is not the same thing. So make sure the plus or minus is out front. But after that, you can kind of jumble those up whatever order you like. You could even 3 root 2 times I. But be careful, make sure it's clear that the I is not under the radical. That's the danger of putting something after the radical is people do things like that. They extend their radical like just halfway and like, oh, is it under there or not? I can't tell. So don't do that. Which is why we usually put it in front so that there's no confusion about whether it's under the radical or not. Alright, square root method. Easy, preferred, but not often usable. Let's see. Next method. I think you know this method. If it won't factor, what are you left doing? If you get one that won't factor. I can tell by your smiles you know what's coming. You're like, maybe if I don't say it, we won't have to do it.
What is it?
The quadratic formula. The quadratic formula. You hear that song?
No, I don't like that.
You know this song though, maybe. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Miss Seagrave's doing singing the song.
You missed out. You got me singing. And it's recorded, so if you really enjoyed that, YouTube later and you can just repeat that, and some of you guys can probably edit that down and just put that on repeat and turn it into a TikTok and make me go viral with my quadratic formula song.
Hey, I forgot about this.
And I'll even put some musical notes for people and just to remind you that there's a song that goes with that.
Did you make the song?
I did not make the song. Someone figured that out long ago, and ever since I heard it, I can't see the quadratic formula without singing the song. So it's how I have it memorized. The great news about the quadratic formula is that it always works. So some of those other methods, some things factor, some things don't. Some things you can take the square root of, some things you can't. You can always, always, always use the quadratic formula. And in fact, on the worksheet and on the test, there's a section that says solve however you like. Some people will quadratic formula all of them every time. That way they're doing the exact same thing. That doesn't seem like the most efficient way to go, but if you got a method that works, there's nothing wrong with that.
How do you know when you need to use the quadratic formula? Do you just have to try the other?
That's a great question. I'll repeat it for the video. How do you know when to use the quadratic formula? Right, if you can't factor it, and it's not square rootable, then you have to use the quadratic formula. And occasionally, like, you'll think one that is not factorable that really is factorable, but that's still fine since this always works. So if you can't factor it, whether it's factorable or not, if you can't figure it out, then you go to the quadratic formula, which means occasionally you might use the quadratic formula when it could have been factored. But it always works, so you're okay. Let's back up and go real slow through this for the first time. After this, some of you will start breezing through this. For x squared minus 2x minus 1, what is a equal to? 1. Good. Right, so like when students first learn this, they want to say a is equal to x squared. Like, no, a is the number in front of the x squared. And yes, there is a number in front of the x squared, and it's 1. What about b? Negative 2. And c? Negative 1. After you do this a couple times, you're not going to be writing down what a, b, and c are. You're just going to start plugging them in, and that's fine. But maybe it's helpful to sort of slow down and write down what a, b, and c are. So x equals negative, be careful, negative 2 plus or minus the square root of b squared minus 4ac all over 2a. Then it's just cleanup time. So now it's, once you have it memorized, like, it's no big deal now, or shouldn't be. So that's 2 plus or minus the square root of, what do we have, 4 plus 4. So be careful, there's lots of signs that you have to be careful about. Square or negative, we get a positive 4. 4 plus 4 is 8. All over 2. Lots of simplifying. Like the square root of 8 becomes square root of 8 becomes 2 root 2. Oh boy, we got 2's everywhere. Which of the 2's can simplify? Okay, so the bottom one with it's hard to even say. The first 2? How about this? Which one cannot be canceled? The radical. There we go. Because, let me show an extra step here. That's the same thing, and that makes it a little more obvious that you can divide it. If you're going to divide the 2, make sure it divides into everybody. So 1 plus square root 2 all over 2. Whoops, not all over 2. We canceled that 2. 1 plus or minus square root of 2. That simplifying thing, man, that messes some people up. Let's do one more, just a side note here. Yeah, plus or minus. How about 6? So completely separate problem. Let's say we work the problem, we get all the way down to 6 plus or minus 4 root 3 over 3. What can we reduce on that? Well, if you reduce the 6 and the 3, you're going to have to split it up. Because if you're going to divide by 3, you got to do all over 3. So you either leave it like that. If you want to divide it up, you can. But that 3 is still under the other one. So either one of those answers would be okay. But yeah, if you divide by 3, you got to split it up because you still got to divide all of it by 3.
So on the test, then would you take both?
I would accept either one of those because it kind of depends on the situation as to like which one of these would be preferred. That they're close enough to the same thing that either one's fine. If it's a multiple choice test, I don't even know which one we'd put, but hopefully you could recognize that those are the same. All right, your last method is your least favorite method. Quadratic formula is not the worst method, right? Like, you've got to know the formula. I mean, some people, they end up thinking it's the best method because it always works. Once you know the formula, it's fine. The last method, it's not terrible. It's just that you use it once a year and then you never use it the rest of the year. And so this is the 1 week out of the math year where we use it. And then, so hopefully you remember it, and then you'll forget it until you need it next year, which you will need it next year. So, anybody know what method we're headed toward here? Complete the square. This only works if a equals 1. You can force a to equal 1 by dividing by a, but then sometimes you get weird numbers the rest of the way. We're only going to ask you to do it if a is 1, because other than that, it gets kind of crazy. So I'm going to list the steps and work a problem sort of simultaneously. So our problem is x squared minus 4x minus 7 equals 0. Anybody have any idea how to start complete the square? It's just been way too long. Let's move c over. Like, get c out of the way. X squared minus 4x. And you notice I left a blank there because we're gonna fill that blank in a minute. X squared minus 4x equals 7. The next step is super easy, but it's super important, so I'm going to call it its own step, even though it's really not that big a deal. What's b equal to in this problem? -4. And then the next step, I'm going to group a bunch of things together. This is sort of the heart of the problem. Half it, square it, add it. Half it, square it, add it. Half it, square it, add it. Those all run together real quick. So you found b. Half of b over 2 is -2. Square it, you get 4. And then add it. You got to add it to both sides. Half it, square it, add it. So find b, and then half it, square it, add it. If you make it that far, the rest is kind of home free, because now we're going to factor. So that would be x minus 2 squared. By the way, the factor is always b over 2. So it's not really like think about it, figure it out factoring. It's always b over 2. And then lastly, although this is also more than one step, kind of built into one, solve using square roots. So I can square root both sides. And then move the 2 over. And there's my answer. Half it, square it, add it. Are we okay with that?
Yeah, I was making sure. I thought you put 2, like, it would be a square root of 11 plus 2. But
You could write it as plus or minus square root of 11 plus 2. But usually the plus or minus thing comes second. I don't know if that's to match the quadratic formula. But either one of these answers is acceptable. All right. So I hope this is review, because this is like a week or a week and a half worth of Algebra 2 right here. Like in Algebra 2, you take a day or two on factoring, and you might even have a day on the square root method, and then a day or two on the quadratic formula, and then a day or two on complete the square. And then you get to pre-cal, it's like, yeah, remember all that? Let's do it all today, and then we'll move on. So it goes quick, but hopefully you've seen it before. Reminder that on Friday, worksheets 1 through 3 will be due.